In this video, we're going to introduce you to the manometer, which is one of the oldest pressure measurement devices still in use today. A manometer is one of the most accurate devices for measuring pressure in the lower ranges. Since manometers are so accurate, they are often used as calibration standards. Some typical industrial manometer applications include fluid flow measurements, HVAC systems maintenance, residential or commercial furnace gas valve pressure measurement. All right, let's get started. All manometers operate on the principle that changes in pressure will cause a liquid to rise or fall in a tube. There are several different types of manometers, and we will discuss many in this video. As mentioned earlier, all manometers operate on the principle that changes in pressure will cause a liquid to rise or fall in a tube. Let's look at a U-tube manometer, as it is probably the most common manometer in use today. We'll discuss how it is used to measure pressure. As we said earlier, a manometer is filled with a liquid. Typical manometer liquids are mercury, water, and light oils. It's worth saying here that mercury was a common manometer fluid in the past, but has largely been replaced due to its environmental and health hazards. Quite often the liquid is colored to help detect the fluid movement. The tube is filled until both sides are approximately half full. When the pressures are equal, the column of liquid on each side will be at the same height. This is usually marked as 0 on a scale. With both sides of the manometer open to the atmosphere, the fluid level on one side will be the same as the level on the other side, because P1 equals P2. Okay, now suppose one end of the U-tube manometer is connected to an unknown pressure P1, whose value must be determined. The other end is left exposed to the atmospheric pressure, P2. The difference in the height of the liquid on the two sides of the tube is the differential pressure. In this case, the manometer provides a gauge pressure measurement because it is referenced to the atmosphere. Okay, so the total difference in liquid height is 4 units. And this is where the pressure measurement becomes interesting. What does the 4-unit difference represent? Let's assume our U-tube manometer is filled with water. That means that our pressure differential is 4 inches of water column. From our previous videos, you know that inches of water column is a unit of pressure measurement. Using conversion charts, we could easily convert 4 inches of water column to 0.144 psi gauge pressure. As you can appreciate, a U-tube manometer filled with water is only capable of measuring very small pressures. To illustrate, let's apply a pressure of 5 psi to the P1 side of the U-tube manometer. Oops, we don't want that to happen. What if we wanted to accurately measure very low pressure values? If we replace the water with a Merriam red oil fluid, we will get a greater difference in liquid levels. Why is that? Water has a specific gravity or relative density of 1, while Merriam fluid is an oil and has a specific gravity of 0.83. We will get a much larger difference in liquid level with Merriam fluid, resulting in more accurate pressure measurement. In some cases, vendors will provide a U-tube manometer scaled directly in pressure units, such as kilopascals. Manometer users must be aware of meniscus error. Meniscus occurs when the particles of the liquid stick to the sides of the glass tube. Depending on the direction of pressure applied, the meniscus can be concave or convex. Either way, a reading error may occur. Let's have a look at a couple of other types of manometers. One common type of manometer is a barometer, used to predict weather conditions by measuring atmospheric pressure. A barometer consists of a glass tube with one end sealed. An evacuated tube has its open end submerged in an open container of mercury. The pressure exerted by the column of mercury is balanced by the pressure of the atmosphere. The glass tube is calibrated in pressure units. Any liquid could be used in a barometer, but mercury is used because of its high specific gravity. A mercury barometer needs to be at least 30 inches tall. A water-filled barometer would have to be more than 33 feet high. A manometer that provides even better accuracy than the YouTube manometer is the inclined manometer. This manometer has a well that contains the liquid and a transparent column. The column is mounted at an angle. The pressure is indicated by the vertical amount the liquid rises or falls in the column. Because of the incline, a small change in pressure will cause greater movement of the liquid in the column. If you want to learn more about pressure measurement, be sure to check out our other videos called DP Level Measurement Explained, What is a Pressure Sensor, and Pressure Transmitter Explained. You can find the links to these videos in the description. Okay, let's review what we've covered in this video. A manometer is one of the most accurate devices for measuring pressure in the lower ranges. Typical manometer applications include measuring pipe fluid flows, HVAC system pressure, and gas pressure. All manometers operate on the principle that changes in pressure will cause a liquid to rise or fall in a tube. Typical manometer liquids are mercury, water, and light oils. One end of a YouTube manometer is connected to an unknown pressure, while the other end is left exposed to the atmospheric pressure. The difference in the height of the liquid on the two sides of the tube is the differential pressure. Other types of manometers include the barometer and the inclined manometer. Want to learn PLC programming in an easy-to-understand format and take your career to the next level? Head on over to realpars.com.